Hey everyone, we are looking at the derivative of a quotient of two functions. Remember, quotient just means divide. So if you have two functions that are divided, so u over v, u and v are the functions, just like when we had with the product rule, it would be so nice if it was just u prime over v prime, but of course it's not. It's actually this whole thing. So u prime v minus uv prime over v squared. So looking at the top of that, it looks a lot like the product rule, doesn't it? Which is really nice for memorizing purposes. The only difference on the top is we have a subtract instead of an add. If we were in the building and we had more time, I would show you where this comes from, but sadly we just don't have time. If you really want to know, check out page 138, or perhaps you could Google it and find a video for the proof. Some people like that kind of thing. I actually do too. I think it's fun in a weird sort of way. So let's look at an example. So again, it's a good idea to, just like with the product rule, it's a good idea to list things out. So we have our u is our top, so u is sine of x squared. And u prime is derivative of the outside, so cosine. Keep the inside the same, x squared times derivative of the inside, 2x. And I am going to rewrite that as 2x cosine x squared. That way it's just a little bit like more compact to write it. And then for our v, we have 3x plus 1 to the fourth. And then v prime is going to be, I'll have a 4. I'm going to plan ahead here. I have 4 times the inside, but then I'll have the times derivative of the inside, so times 3. So I really have a 12 there. So chain rule. And then so 3x plus 1 cubed. And then also, because we need it, a v squared. So if we are squaring 3x plus 1 to the fourth, we get 3x plus 1 to the eighth. Because if I threw this guy in parentheses and threw an exponent of 2 on there, you would have a power raised to a power. So you'd multiply that exponent. So we have that, all of this set up for ourselves. So then for our derivative, it's a matter of just plopping things into place. U prime, 2x cosine x squared, times v, 3x plus 1 to the fourth. And then minus u, which is sine of x squared, times v prime, which is here, the 12 times 3x plus 1 cubed, all over v squared, 3x plus 1 to the eighth. And we could do some cleanup on this, but for the sake of a little bit of time, we're not going to. We're going to see some similar things that we could clean up. Because if you notice, we have 3x plus 1s in all of those pieces. So there is some cleanup possible, but we're not going to do it because we're going to see that on our next example. Okay. This is where things get a little crazy. Kind of like when we had a product that actually was this exact thing but multiplied. So I just kept the same couple of pieces. So u is our 6x minus 7 to the fourth. U prime is, it's 4 and then times 6, so 24. And then 6x minus 7 cubed. There's a chain rule there, and I didn't show all the steps just for the sake of time. V is 2x plus 1 to the eighth. V prime is 16, because it's 8, and then you have the times 2 from the inside. So 16 times 2x plus 1 to the seventh. And then v squared is all of this, the 2x plus 1 to the 16th. I'm not going to write that just so I have a little more room to write. So our derivative then is going to be, yeesh, brace yourself. Okay, u prime, 24 times 6x minus 7 cubed times v, 2x plus 1 to the eighth, minus, I usually make that minus really dark just to bring it to my attention a little bit, u, which is 6x minus 7 to the fourth, times v prime, which is the 16 times 2x plus 1 to the seventh, all over v squared, so the 2x plus 1 to the 8th getting squared is to the 16th. Okay, so this is step 1. Well, this is half of step 1. We derived it. We're going to simplify, which once again, this is going to feel a lot like complicate. So once again, I've done the analogy. I've replaced all the 6x minus 7s with an A and all the 2x plus 1s with a B. So if I were to clean this guy up, I'm going to factor the numerator. So I have, again, the 24, the 16th, the largest that goes into both is 8. And then I can factor a cubed out of the top, and I can factor a b to the 7th out of the top, leaving me 3b minus 2a. This is like what I did before. So if I distribute that, I would get back to that top. And this is over b to the 16th. And then I can go, oh, look, this b to the 16th and b to the 7th, that can be b to the 9th in the downstairs, and that b to the 7th on the top is gone. So it actually does a lot of cleanup there. So going back to our problem, we ready? We can do this. I promise we can do this. So y prime is, I have my 24, my 16, I can factor an 8 out. And then the 6x minus 7s, if there's 3 here and 4 there, I can take 3 of them. The 2x plus 1s, there's 8 in this first wad of stuff and 7 in the second wad of stuff, so I can take 7 out. And then I'm going to do a square bracket, just like I did on the product rule stuff. And then I have 3, because 8 times 3 is the 24. 6x minus 7 cubed, I have enough. 2x plus 1, there's 7 here, I need 8, so I need another 2x plus 1. And then minus 8 times 2 gives me the 16. 6x minus 7 cubed, I need another one, so to get to the 4th, so 6x minus 7, and then double checking 7 of the 2x plus 1s, I have those. And that is all over 2x plus 1 to the 16th. So now I can do a couple of things. I can get rid of 7 2x plus 1s from the top and 7 from the denominator, and leaves me a 9. And then clean up the inside of those square brackets. So now I have y prime equals 8 times 6x minus 7 cubed. And since there's subtraction, there's too many mistakes possible. I'm going to do this in 2 steps. So 6x plus 3 minus 12x, watch your signs, plus 14. When you're thinking about all the calculus stuff, it's so easy to mess up the algebra. And all of this is over 2x plus 1 to the 9th, because remember, we got rid of some of those. And then cleaning up the inside of that set of parentheses on the top, we have 8 times 6x minus 7 cubed. And then 6x minus 12x, I get negative 6x. 3 plus 14, I have plus 17. Over 2x plus 1 to the 9th. So this does look tidier than what we had started with way back up to here. So there's really 2 pieces to this problem. There's one, can you do the calculus? Can you get through step 1? And then the next piece is, can you get through all the algebra to simplify this? Because like on the AP test, this question would show up as a multiple choice, so you would have to find this find your way to this last spot. But once we have it here, we can then answer questions like, where do we have horizontal tangents? Well, you have a horizontal tangent if your derivative is 0. The derivative of 0 happens if the numerator is 0. So horizontal tangents happen if 6x minus 7 is 0, or if negative 6x plus 17 is 0. So x would be 17 over 6, or 7/6. And the next bit is y where is the derivative undefined? And that would be at negative 1/2, because you have a divide by 0 that would happen here. So if x is negative 1/2, y prime is undefined. And actually, y is undefined there as well because of the divide by 0 that's going on with that. So y is not continuous. Just because a derivative doesn't exist at a point doesn't mean you're not continuous. So you have to watch that really closely. And that is our quotient rule.